okay? Lastly, this is the last slide we will cover today. Talking about osmosis and how it relates to oxygen transport. All right, so we're almost done. Hang with me. All right, let's talk about oxygen transport for just a minute. You see two colored capillaries here, a red capillary and a blue capillary. This red capillary on the left side indicates blood that is freshly, I'll just say freshly oxygenated blood. So we have freshly oxygenated blood. So we have high concentration of oxygen in our blood, okay, when it's red here. And because of that, because oxygen is a gas, we have higher blood pressure as well. So we have a high concentration of oxygen, therefore we have higher blood pressure because gas creates pressure in the blood, all right? In our surrounding cells, if we look down here, cells are constantly at work using oxygen and creating waste, okay? They use oxygen, they create CO2, which we know we have to exhale. So this freshly oxygenated blood is coming from the lungs, okay, traveling down to surrounding tissues and cells. Down here at the bottom, these surrounding tissues and cells have a low concentration of oxygen and therefore a lower blood pressure, okay, relating to oxygen, okay. And however, these surrounding tissues and cells, so I'm going to draw an arrow here. These are surrounding tissues and cells. Whoops. Okay, low concentration of oxygen, lower blood pressure related to oxygen. But they do have a high concentration of CO2, okay? And a higher concentration of other wastes. Different, and when I say waste, just different kind of particles and things that they need to get rid of. The main one we're concerned about is CO2. And additionally, freshly oxygenated blood has hardly no CO2. So it's got a low concentration of CO2, okay, in freshly oxygenated blood. So what happens here is we have a gradient set up. And remember, a gradient, in a gradient, solvent moves from low concentration to high concentration. But actually, we've written that earlier. I don't need to go into that here. I just want you to know there's a gradient primarily related to different concentrations of oxygen and different concentrations of CO2. Okay, so because of that, when this freshly oxygenated blood comes down here and crosses into areas where we have surrounding tissues and cells, okay, in the tiniest capillaries, what happens is because that blood has high concentrations of oxygen and the surrounding tissues and cells have low concentrations of oxygen, oxygen is going to be pushed out to surrounding tissues and cells, and CO2 and waste are going to be reabsorbed into the blood to be carried out of the body, okay? So with that, we call the process of oxygen transport filtration. I'm going to write it on the other side. I'm kind of running out of room over here. Okay, so the process of oxygen transport from areas of high concentration to low concentration We call that filtration. Okay, and process of CO2, moving from high, CO2 concentration to low, process of CO2 moving from areas of high CO2 concentration to low CO2 concentration. We call that reabsorption. Reabsorption. Okay, that might need to be a B actually. Reabsorption. Okay, so the process of oxygen transport moving from areas of high concentration, high oxygen, which is freshly oxygenated blood, to low oxygen concentration, which is surrounding tissues and cells, that's filtration. You need to know that term. Process of CO2 moving from areas of high CO2 concentration to low, that's reabsorption, and that's why CO2 moves from surrounding tissues and cells into the blood to be exhaled. Okay. Lastly, I'll just mention this is also how dialysis works for patients with kidney failure. We filter their blood out of them, okay, and it runs through a pump. That pump shoots the blood through this kind of dialysis bag. So this right here is the dialysis bag. In the dialysis bag, we have the dialysis solution, okay, and that's going to help. Let's see, the dialysis solution is going to be a fresh, clean solution. So there is low concentrations of waste in the dialysis bag, but the blood has high concentrations of waste. And that's what causes waste to move out of the blood, okay, into the dialysis bag. And it also filters good things in, okay? It's all due to a gradient. And it gets good things back in our blood. It removes waste. Then it runs it all through a filter and pumps it back into the patient. So just another way osmosis works, and we can use the good of osmosis to do good things for patients who really need it. So that ends our Chapter 9 lecture series. That is the end, complete end of Chapter 9. And we